Alright, so Chapter 5 is kind of going to be a mishmash and a hodgepodge of a bunch of different things. It is the first of two chapters we will look at in pre-algebra that will focus on geometry concepts. So, first lesson is about points, lines, planes, and angles. A point names a single location. It'll be shown with a dot and named by a capital letter. When we name these things, we have to say point A. A line is perfectly straight and extends forever in both directions. In order to name a line, we will have usually 2 points on the line. It is possible it could be named with an italic or a cursive letter, single one, but more often than not, it's going to be 2 points. And in the conventions over here, you can see it says line AB, line blank, and then AB with a line above them. The blank is BA. The name of a the name of a line can be reversed. Line AB and line BA are the same thing. The one you want to use, though, when you're naming lines is this guy on the end. The 2 points on the line to name it, AB, with a little line above it. And yes, arrows have to be on both ends of that line. It's the shorthand notation, and it's what we will use, or what you will use in geometry when you get to that class in 2 years. Next up is a plane. A plane is a perfectly flat surface that extends forever in all directions. Here, this is plane ABC, and it could be BAC, CBA, whatever. Oftentimes, planes will also have like a curly letter, a cursive or an italicized letter, something like that. So this could be plane N. But we use 3 letters when there's no italicized letter. A line segment is the part of a line between 2 points, so there'll be no arrows on a line segment. 2 arrows on a line, no arrows on a line segment. To write line segment AB, we write AB, put a line above it with 0 arrows on it. Line segment BA is the same thing. Line segments and lines are reversible. A ray is part of a line that has 1 point and end point and extends forever in one direction. So a ray will have 1 arrow. We name rays with 2 points. This is ray AB, and you can see in the column the shorthand notation for it. Ray BA is not the same thing. Ray BA starts at B and travels through A. This diagram doesn't have a ray BA on it because if you start at B and go towards A, you run out of space. You end at A. Every line is made up of 2 rays. That'll be a useful thing to realize. So with this, you're going to have to identify some stuff. So name 4 points. Well, there's only 4 points on here. They're Q, R, S, and T. If you use capital letters, you don't have to write the word point. Capital letters are used to represent points. Lowercase letters we use for variables. So an uppercase letter in this situation, I will know you mean it's a point. When it says name a line, the line is obviously here, arrow on each end. So we need to use any 2 of those 3 letters. So that could be line QR. It could also be line QS. It could be line RS. Lots of options here. For the plane, you have to write out the word plane, sorry. I would call it plane Z because we do have this italic identifier up here. Now, could you name it with letters? Yes. The only rule there is you cannot use 3 letters that are on the same line. So you could not name this plane QRS. You would have to use T in your name and then any 2 of the letters on the bottom. Naming a line segment, so here's one line segment, here's a line segment, here's a line segment, and I'm going to do it underneath, here's a line segment. There are 4 line segments on this diagram. Doesn't matter which one you want to use. So I'm going to name segment QS. Just name one of the 4. Ray, so there's a lot of these. There's a ray. There's a ray. There's a ray. There's a ray. And there's a ray. There are 5 rays on this diagram. The easiest one is the one that I think is most obvious, ray RT. But you can use any 2 points on the bottom to name a ray as well. Angle relationships. So first of all, types of angles. A right angle is 90 degrees. An acute angle is between 0 and 90. An obtuse angle is between 90 and 180. And a straight angle is 180. Complementary angles are 2 angles whose sum is 90, meaning if you put them together, they make 90 degrees. Supplementary angles are 2 angles whose sum are 180. Congruent figures are figures that have the exact same size and shape. And vertical angles are angles formed by the intersection of 2 lines. Vertical angles are congruent, equal to each other. So, naming angles. See if I can squeeze all this on one. Yes, I can. Name a right angle. A right angle is 90 degrees. So that could be that, or that, or this, or this. There are 4 right angles on this diagram. So any of them, angle, and then we use 3 letters. I'm going to do the one I highlighted in green, which was starting at A, traveled through D, and went to E. Angle ADE. That is the angle symbol that's before the A, and you must use it when naming an angle. If you just give me 3 capital letters, I have to assume you're listing points. Naming an acute angle. There are 2 acute angles in this diagram. That's one of them, and the other is right beside it. So those are angles ADB or BDE. Name an obtuse angle. There's 1. There's 2. There are 2 obtuse angles. So perhaps angle FDB for that. Could have done CDB as well. Straight angles. You're looking for a line. There are 2 of those. It doesn't matter which one we choose to name. Angle ADF is a straight angle. Now, when we're asked to name a pair of complementary angles, what I want you to do is find yourself a right angle that has another ray in it. Okay, I've highlighted angle ADE because it is split up by DB. So here I have 2 angles that go together to make 90. That means they're complementary. The angles are angle ADB with angle BDE. ADB with BDE. To find supplementary angles, you need to highlight a line and then pick one ray that's coming off of that line to split it. What are the two angles highlighted here? They are CDB and BDE. I'm just going to point out here, we could have instead highlighted DA and used CDA with ADE. And we could have also highlighted DF and done CDF with FDE. And that's just working off of the first line. You could also invert and use that as the line you're going to break up. And then we could break it up with CD. We can break it up with DE. Or we can break that up with DB. So a lot more options on this diagram for supplementary. Now for vertical angles. What I want you to do for vertical angles is highlight two intersecting lines. Now, the key thing about vertical angles is that they have to be opposite. The only thing they share will be the point they touch, D. So basically, these two lines that intersect get cut up into 4 or 5 parts. Part 1, Part 2, Part 3, Part 4, and Part 5. Vertical angles are opposite of each other. They must be the same measurement. The pair of vertical angles here, the way I've numbered with the numbers, are angles 1 and 4. Naming those properly, those would be angle CDA and angle FDE. The reason why 5 is not vertical with 2 and 3 is because 2 and 3 take that portion and split it again. Okay, and I'll highlight this in red. This is what causes the problem. The fact that this second bit here is cut again. So there you can see how to find vertical angles. And here, again, we have vertical angles. So if I highlight my two lines, you can see it's already broken up into 4 parts. So here we have 2 sets of vertical angles. 1 and 3 are vertical, 2 and 4 are vertical. This means that 1 and 3 are the same thing, and 2 and 4 are the same thing. So if they tell me angle 1 is 105 degrees, I need to find the rest. Get rid of that for a second. Now, here's the great thing. Angle 3, automatically the same thing. Automatically 105, just like angle 1. Now, I'm going to re-highlight this. And this. The parts I've just highlighted, the green is a line, and every line is 180 degrees. That yellow bit is splitting that 180 degrees into 2 smaller angles. If we know that one of those angles is 105 degrees, then the other angle must be 180, take away the 105 we have. 180, take away 105 is 75 degrees. If angle 2 is 75 degrees, then angle 4 is also 75 degrees.